we will break it up. We'll do sine and cosine today, and we'll spend probably today and tomorrow, at least, maybe the next day, talking about everything with sine and cosine. Then we'll get into the other functions after that. This will be a pretty quick chapter. There's not a lot of information in it, really just talking about these graphs. Now, in general, we have graphed tons of things, not in trig, but in algebra. You know, we've graphed parabolas and cubics and square roots and all of those things. And anytime you start graphing, if you don't know what the graph is going to look like, what do we end up making? What do we do to get points on our graph? Make a t-chart, right? We just plug in, pick an x, plug it in, see what we get out for the y. And we do that until we have enough points that we can draw the complete graph. So that handout that I gave you is what we're going to do when we are making our t-charts to try to figure out these graphs. Now I do have just for your notes first, all of these trig functions are what are called periodic functions. So you'll hear me say that a lot. And periodic functions are just functions that repeat. If you think about this circle, you can keep going around the circle as many times as you want. So these graphs do not just start and stop. They are continuous. They will keep going forever. When I look at sine and cosine, I'm going to talk a lot about the period of these functions. And the period is how long it takes before they start repeating. If you think about your unit circle, they repeat after you go all the way around the circle. So how far is it to go all the way around the circle? 360 degrees, which is 2 pi radians. So in general, we are going to use radians. So sine and cosine, the ones we're looking at today, they're periodic because they keep repeating every time you go around a circle. So their period is 2 pi, because that's how long it takes before they repeat. So we'll do this on our handout, and that way you have one handout at the end of this that has all 6 of your graphs in one place, so it's easy to reference when you need to look back at something. You'll notice I kind of picked already our x values. I said 0, pi over 2, pi, 3 pi over 2, 2 pi. What are those points? Right, you're in degrees, 0, 90, 180, 270, 360. So those are the quadrantal angles. They lie on the axes, so it just kind of breaks things up. So if I want to find sine, what is the sine of 0? So think about your unit circle if you want. When we filled this out, sine was the y. So your y is 0. All right, at pi over 2, what is your sine? 1. At pi, what's sine? At 3 pi over 2, sine is? And at 2 pi, back to 0. All right, let's start filling this out. So this is my xy axis. My high point is 1. My low is -1. So my points on the x, we had our 0, pi over 2, pi, pi over 2, and 2 pi. So I have 0, 0. Pi over 2 is 1. Pi is 0. 3 pi over 2 is -1. And 2 pi is 0. Does everyone understand how we got those points? Now, after we start graphing these and you have an idea of what your picture is supposed to look like, that's going to be all you need to get the graph. Since we've never graphed this before, we might need a little bit more. So I'm going to put some more on mine just to kind of talk about some of these points. You know, our common ones, we did 30, 45, and 90. So like 30 degrees or pi over 6. What is the sine of 30 degrees? 1/2. 45, that would be right there in the middle. What's the sine of 45? All right, put that in your calculator. Tell me what that decimal is. About 0.7. What about at pi over 3? Or 60 degrees? What's the sine of 60? So plug that in for me. What is that as a decimal? So here's what I'm wanting you to see. Is it just like a straight line between these points? No. This is a curve. Now we can keep doing this on the other side if we want to continue to plug in those points. But all it's showing us when we do all those others, it's just showing us that this is not a line. These are curves. So from now on, we won't need any of those intermediate points. We just need the quadrantal ones because we know it's curved after that. When I'm looking at these, you know, for our purposes of our graph, please try to space things out evenly on your x-axis. We know from 0 to pi over 2 is 90 degrees. And that's the same as the distance between pi over 2 and pi, so your points should be evenly spaced on the x-axis. Your graph should be curved. If I start seeing these zigzag things, that's not going to work. Okay, these are curves. A lot of times you'll hear sine and cosine talking about waves. So it's just a nice curve. But we know, does it really just start at 0 and stop at 2 pi? No, because you could keep going on your circle. So really, you know, this graph of sine could keep going forever. And we will talk about that. But I just want you to recognize, even though I only graphed it from 0 to 2 pi, after this, what's it going to do? It just keeps repeating. It follows the same pattern forever. Domain. What x values do I hit on this? We only graphed from 0 to 2 pi, but we said it's going to keep going. So what's my domain? My range, though, what y's do we hit? Everything between -1 and +1. If you remember, back in the very first chapter, we talked about sines and cosines, and we did their domains and ranges for those. And back then, we looked at triangles to help figure out what it could be. But now we have that graph to kind of help us visualize.
And it would always be the same domain range for some reason.
The domain will always be the same. The range could change, and I will show you situations where that happens. Okay, let's go ahead and graph cosine. So we'll do the same points, the quadrantal angles. We know on our unit circle cosine is the x. So what is the cosine of 0? 1. Or if you do the hand trick, square root of 4, which is 2 divided by 2, is 1. At pi over 2.
0.
At pi. At 3 pi over 2. And 2 pi is back to 0 where we had 1. So I'm going to label my points. cosine of 0 is 1. Pi over 2 we get 0. Pi we get -1. Pi over 2 is 0. And 2 pi is 1. We could put in more points, but all that's really going to show us this is just like sine. It's a curve, so you're not doing straight lines here. And again, does this really just start at 0 and end at 2 pi? No. If you wanted, you could keep drawing it. This is really kind of like the graph of sine, isn't it? Yeah, just kind of started, sine started at 0 and cosine starts at 1. But otherwise, they're both just these waves that keep going.
So how do you know where to put the dots to go through?
Oh, like this that I put? Or are you talking about the points?
The coordinates, yeah.
I was plotting these. So 0, 1. This is like your x, so your x is 0, your y is 1. So when x is pi over 2, my y is 0.
Okay.
What would be the domain of this? We know it keeps going. What about the range? I'm going to ask you another question. I want to know if these are even or odd functions. Even and odd, that's something we did in algebra. Remember, even means symmetric to the y-axis. Odd means symmetric to the origin. The O's go together. Odd is origin. Even is the y-axis. This will have some pretty important properties for us as we move forward. If we think about the graph of sine. So looking back at that first one. If you fold that thing over the y-axis, will it overlap itself? On the other end, it will be going down next. So if I just flipped over the y, do those things overlap? If I flip over the origin, that means you flip it over the y, then you flip it over the x. Then it overlaps. So, what that means, sine is odd. The definition of odd we had in algebra said that if your x was negative, it will make your y negative. We will use this property when we start graphing some transformations of these trig functions. It's a lot easier to have a negative out in front than it is to have it on the x. So because sine is odd, if the angle is negative, you could just pull that out and get the function. If I look at cosine, what kind of symmetry would cosine have? Even. If you flip that on the y-axis, it does overlap itself. So the definition of even says if you have a negative on your x, you get the exact same thing as when you have a positive on your x. So you might want to jot those down in your notebook. And we will be looking at these for each of the 6 trig functions. But we'll use that property to help us on some of our graphing. say I asked you to graph y equals 2 sine of x. So what x's did I tell you that we needed to plug in when we do this?
0, 2,
Please make every effort to space those things evenly. They represent your quadrants, so we know there is equal distance between all of them. Your graph will be skewed if you have two of those really close together and then two really spread out. I do expect you to label those points on the x-axis. So we really have a total of 5 points that we're looking at. So we can think of this as kind of making a T-chart. If you plug in 0, sine of 0 is 0, times 2 is, all right, so 0, 0 is on my graph. If I plug in pi over 2, sine of pi over 2 is 1, times 2 gives me 2. Pi over 2, we get out 2. At pi, what's the sine of pi?
0.
Times 2 is still 0. 3 pi over 2, what's the sine of 3 pi over 2? Negative 1 times 2. And 2 pi, that's the same as 0, so sine of 0 is 0, times 2 is 0. So here's my graph. We know these are always going to be curved. How is this different from my regular sine? My range changed. Sine, the one we graphed before, looked like this. So my regular sine had a high point of 1 and a low point of negative 1. But once I put this 2 out in front, my highest point is 2 and my lowest point is negative 2. If you think back to transformations in algebra, a number out in front is stretching and shrinking your graph, so it's like taking off your y's times 2. It just made it get taller. So if I put a 3 sine of x, what do you think the high point would be? 3, and the low would be negative 3. Okay. Let's look at ½ cosine of x. So we did one with sine, let's do one with cosine. Do you have any predictions what this will look like?
Smaller, yeah.
So the points on my x are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Let's see if you're right. Can I just talk through my points, or do you want me to write them down? I'll go ahead and write it down one more time. Okay. What is the cosine of 0? 1 times 1/2 is 1/2. So at 0, we get out 1/2. Cosine of pi over 2 is 0 times 1/2 is still 0. at pi. Cosine of pi is -1 times a half. Okay, so 3 pi over 2, cosine of 3 pi over 2 is
0.
times 1/2 is still 0. And 2 pi is the same as where we started. Cosine of 2 pi is 1 times half is 1/2. So you predicted that this would look like the cosine graph, but just shorter. Were you correct? Yeah, cosine normally started at 1 and bounced back and forth between 1 and -1. So all this did was a vertical shrink. It changed my highest point to 1/2 and my lowest point to -1/2. Okay, so this number actually has a name to it. It's talking about the height of our curve, that number out in front. So if there's nothing there, my height is 1. If it's a 2, my height is 2. If it's a 1/2, my height is 1/2. It is formally called the amplitude. And the definition is half the difference between the maximum and minimum points. Okay, right now we can kind of think of it as just the height. The reason it's stated that way is because if we shifted our graph up or down, then the amplitude would not necessarily be the high or low point. You know, if you had an amplitude of 2, but then you moved your graph down 1, that would change it. So amplitude is that number out in front, and it's just half the difference between the maximum and minimum. When I'm talking about amplitude, it is always a positive number. And it's the coefficient on the trig function. If I say y equals sine of 2x. So I know if the 2 were out in front, that would change my amplitude. Let's see what happens if it's attached to the x. So if we graph this, here are the points we've been using. Over 2, pi, 3 pi over 2, and 2 pi. What is the, if I put in a 0, so 2 times 0 is 0, sine of 0 is 0. If I plug in pi over 2, 2 times pi over 2 is pi. What's the sine of pi?
0.
Okay, if I plug in pi, 2 times pi is 2 pi. What's the sine of 2 pi? 0. If I plug in 3 pi over 2, 2 times 3 pi over 2 is 3 pi. The sine of 3 pi would be the same as sine of pi, which is 0. If I plug in a 2 pi, 2 times 2 pi is 4 pi.
Wait, how did you get 3 pi?
So 2 times 3 pi over 2. And we've talked about if this angle is bigger than 2 pi, you subtract 2 pi from it.
Oh, let's use that.
So that's the sine of pi. So if I plug in 2 pi, what am I going to get out? 0. So does that mean that this thing always equals 0? That's what it looks like from our points. What would happen if I plugged in pi over 4? Pi over 4 is like 45 degrees, so it's in the middle here. 2 times pi over 4 is pi over 2. What's the sine of pi over 2? 1. If I put in 3 pi over 4, that would be right here. 2 times 3 pi over 4 is 3 pi over 2. What's the sign of 3 pi over 2? Negative 1. So this graph, it's still a sine. What changed? How is this different from the regular sine graph?
It's going on like 45
Yeah. Normally, sine looks like this. So, what this 2 did, it's made it get skinnier. That black one I looked, how many full periods of sine did I graph originally? A period is how long it takes until it starts repeating. So I have 2 complete cycles of sine, right? So when I put a 2 there, I got 2 graphs of sine in that interval. So that 2 changed how long it took to repeat. It changed the period. If I made it a 1/2, what do you think that would do? Stretch it out, and it would have to go all the way to 4 pi before it would start repeating. So in terms of trig functions, when you have a number multiplied with the x, that changes the period of the graph. It changes how long it takes to repeat. And so to find the new period, find out when it repeats, all we have to do is 2 pi divided by that number. I have been graphing these by plotting points, and that is perfectly acceptable, and we could continue to do that. But it can become annoying sometimes. You know, that last one we put in all of our regular points and we didn't have what we needed. We had to go back and pick more. And so sometimes it's a little bit of work to plug in points. We are going to actually use a certain strategy for graphing our trig functions. So the 4 things we are going to do when we graph. I'm going to ask you questions. So the first thing we'll do is find our amplitude. That will give us our high and low point. Then we'll find the period. That's how long it takes until it starts to repeat. Then we will find our count by, which I'll explain what I mean by that here in a second. And then we will sketch the graph. So we will actually do all of this without making the t-chart, just based on what we know of the graphs of sine and cosine too. We are going to graph y equals 2 sine of 3x. So my first question is amplitude. Can you tell me what the amplitude is here? Amplitude is just your coefficient. So our amplitude is 2. Then we will find the period. The normal period for sine and cosine is 2 pi. That's how long it takes them to typically repeat. I told you to find the period, you have to do 2 pi divided by the coefficient on x. So that would be 2 pi over 3. We prefer to keep things in terms of pi if we can. So if it were like 2 pi over 4, I would want you to reduce that to pi over 2. But I don't want to change 2 pi over 3 into a decimal. Just leave it like that. Now, here is the piece I haven't talked about yet. I want to find my count by. What I mean by that, when we graphed this last one, we found out that our regular points, the 0, pi over 2, pi, 3 pi over 2, 2 pi, weren't all that helpful, right? And so I had to end up using 0, pi over 4, pi over 2, 3 pi over 4, and pi. So I need to find a way to get those points. To do that, we had to think about how long it took for this graph to repeat. And then we want to split it up into the 4 quadrants. So to find our count by, we will take our period. The period is the length of time until this thing repeats. So my entire period here is 2 pi over 3. So I'll take my period, the 2 pi over 3, let's use that number. And I want to divide that by 4, because there are 4 quadrants. Think about your circle. It has 4 quadrants. I do not want decimals, but you can use a calculator if you get hung up on that. Just don't put in the pi. So you would do 2/3 divided by 4. Put that in fraction form. And what does that give you? Pi over 6. This is actually everything I need to draw my graph. So my amplitude is 2. That means my high point is 2 and my low point would be -2. I start at 0 and then my count by is pi over 6. So the next point is pi over 6. All of these quadrants are equally spaced out. We should have a total of 5 points because we start and stop at the same point. And so all we're going to do is just keep adding our count by. So we're at pi over 6, so I add my count by to get to the next point. Okay, if you get hung up on these fractions, you're welcome to use calculators, just don't put in the pi. So it would be like 1/6 plus 1/6. So that's 2 pi over 6, which reduces to pi over 3. Okay, so to get the next point, we're at pi over 3, so we have to add our count by. Add pi over 6. So pi over 3, that's like 2 pi over 6 plus 1 pi over 6 will be 3 pi over 6, which is pi over 2. To get the next point, we're at pi over 2, add your count by. So 3 pi over 6 plus 1 pi over 6 will be 4 pi over 6, which reduces to 2 pi over 3. So I expect those points on your axis. Now, I'm graphing sine. So sine, if you look back at our original graph, sine always starts at 0, and then it goes up. So my first point would be at 0. When I get to pi over 6, it should be up at its high point, which was 2. Then it comes back to 0, goes down to its low point, which was -2, and then back to 0. You could always double check yourself. You know, if I plug in these points to the original, this is what I should get. If I put in pi over 6, 3 times pi over 6 is pi over 2. Sine of pi over 2 is 1, times 2 is 2. So I didn't just make this up. These are the points we get if we plug in points. This is just a faster approach to get there. Questions on how I got to that? Okay, I asked another thing. I asked you to do 2 periods. That means 2 cycles of my graph. I have the first cycle. How do you think I would get a second one? Keep on going. So if I'm starting here, all you really need is 4 additional points, because I already have my starting point. And then how do I get those points? Yeah, keep adding pi over 6. So you're at 2 pi over 3 plus pi over 6. So that's like 4 pi over 6 plus 1 pi over 6 is 5 pi over 6. 5 pi over 6 plus pi over 6 is a 6 pi over 6, which is pi. Pi plus pi over 6, so 6 pi over 6 plus 1 pi over 6 would be 7 pi over 6. 7 pi over 6 plus pi over 6 would be 8 pi over 6, which reduces to 4 pi over 3. And the pattern stays the same. We've already done it one time. So here I'm at 0, ready to go up to 2, back down, down to -2, and back. If I asked for 3 periods, what would you do? Keep going. I could ask for as many as I wanted. I'll only do 1 or 2. I won't ever ask for more than that, but. All right. Questions there? Let's see. Let's do one more. Let's do this one. So y equals -3 cosine of pi x. So amplitude is my high point. That's the coefficient. I have a -3 here, but I told you the amplitude had to always be positive. So my amplitude is just going to be 3, but what that negative will do is cause me to flip my graph. If you think back to like graphing transformations, if I said -x squared, that meant an upside down parabola. So a negative will just flip it. Our period. You take your normal period of 2 pi, divide by the coefficient on x. What's in front of x? Pi. So 2 pi over pi, those pi's cancel, and we just get 2. How do we find the count by?
2 divided by 3.
You'll take your period, and you always divide by 4 for the 4 quadrants. So we get 1/2. Amplitude is 3, so my high point would be at +3. My low point would be at -3. For the first period, we need 5 total points, evenly spaced out, because we start and stop at the same point. So we start at 0. Then what would my next point be? 1/2. I'm counting by 1/2. Okay, if you add 1/2, 1/2 plus 1/2 is just 1. Plus 1/2, 1 and 1/2, or 3 over 2. Plus 1/2 is 2. You'll notice my period was 2, and that's where this stops. All right, so what does the graph of cosine look like? Where does it start? It normally starts at 1, or its amplitude, which in this case would be 3. But I flipped it, so it'll start at -3. Then it'll hit your 0, up to 3, back to 0, and down to -3. I know sometimes it's a little challenging to make these graphs perfect, but please make every effort to curve them. You all right? You graph sine instead of cosine. Sine starts at 0, cosine starts at 0. I asked for 2 periods, so how many more points do I need to tack on the end? 4 more. And how do I get those points? Keep adding your count by. So 2 plus 1/2 would be 2.5, or 5 halves, plus 1/2 is 3. 7 halves, and 4. And then the pattern just stays the same. Hopefully your graph is slightly prettier than mine. So I've really taught you all the content here. We're going to do a couple more things with this tomorrow. I'm going to go ahead and give you the homework. Tomorrow I'll do the last couple examples. You will have part of the class period to work on this, and I'll probably start the next section towards the end of class as well. Okay, so this homework will be due on Thursday, but you will not have a full class period to work on tomorrow. It looks like a lot, but 1 through 12, those are all matching questions. So those would be some that you could easily start